All right, why the index cards? We have 3 new theorems I'm going to show you today that involve parallel, and we're going to get back to talking about perpendicular lines. And these 3 theorems are a little wordier than the pieces of paper I had up on the board last unit. So I think it's a good way to study and remember them is by writing them down on the index cards. Okay. So let's talk about our first theorem involving parallel lines. This one's a pretty quick one. Look what I gave you. A is parallel to B and B is parallel to C. And I want to know why A is parallel to C. And I know, this isn't new. It's substitution. Why do I need an index card for that? I'm disappointed if you think it's substitution. Very disappointed. Very disappointed if you think it's substitution. What is substitution reserved for? Equals or congruent quantities, not parallel quantities. So if I know A is parallel to B and B is parallel to C, it makes sense that A and C would be parallel. Makes sense. I don't need a diagram for that. It would make sense that A is parallel to C, but not by substitution. So we need to come up with our theorem. And you guys can help me come up with it. In the givens, what do you know about both line A and line C from the givens? What do you know? They're both parallel to B. So here's the theorem. I have 2 lines. What can you tell me about the 2 lines, A and C? Parallel to 2 lines parallel to the same line. That's what I was given. 2 lines parallel to the same line are, and what's the conclusion? Parallel to each other. Or you can just write parallel, that's fine, but parallel to each other. Questions there? I'm not going to have you write it over again, but that is the theorem. Theorem number 1 of 3 anyway. And now go ahead, grab an index card. Grab an index card. On one side, you pick the side, I don't care. On one side, what you're going to do is write the given I had provided. So what was the given? A parallel to B, B parallel to C. And then on the flip side, you'll write the conclusion that we got, which was A parallel to C with the theorem. 2 lines parallel to the same line. Are parallel to each other. Everyone comfortable with that first one? Not too bad. Any questions? I'm going to give you all 3, and then we'll do a couple practice proofs on using them in statements reasons. All right, so next up. Instead of just giving you the theorem on this one, I want you to do a proof that proves it's true. All right, instead of just giving it to you. What's that? No, nothing is on tomorrow's quiz that we're doing now. All right, so look at my givens. M perpendicular to T and an N's perpendicular to T. So what am I giving you here? I'm giving you 2 lines, M and N, that are what? Perpendicular to the same line. So you would think, based on our last theorem, that they would be perpendicular to each other. All right, well, that's not the case. Let's actually find out what happens here. So m's perpendicular to t, n's perpendicular to t. Anybody got a good reason why 1 and 2 would be right angles then? And this goes back to last unit. Nothing new here. This is a reason we put last unit. Perpendicular lines form right angles. Okay, if they're right angles, then why are they congruent?
All right angles.
There you go. All right angles are congruent. Again, I'm not writing anything new up here for you guys. Oh, and now we go this unit. Now everyone better be on point. If 1 and 2 are congruent, forget that they're right angles. They're congruent. Why are those parallel now? Woo! If 1 and 2 are congruent, why does that make m and n parallel? Come on, come on. What do you got back there, Izzy? Yes, they're corresponding. You just needed to add one key word in there that you forgot out. Corresponding angles, congruent, imply parallel lines. Nice job. Guys are good? So what did we just prove? Ready, go back to the givens. What did I give you? What did I give you about m and n? Those were two lines that were what? Two lines perpendicular to the same line. R, and then what did we just find out and proved? They're not perpendicular to each other. They are parallel to each other. Whoa, 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 we got to talk here. Quick talk, quick talk. The first theorem we did, you were given two sets of parallel lines, right? Second one we just did up here, you're given two sets of perpendicular lines. What if I give you one of each? A set of parallel and a set of perpendicular. Where do I go from there, huh? I give you a set of parallel. I did not want to go that way. See, now I hate that because now I have to do two in a row, and I'm hoping we don't have to stop class here. All right, we're good. Yeah, yep. Okay, one good piece of news here. I'm not going to do the proof that leads to the theorem because we're going to have to use reasons I've never mentioned before, and I don't want the head full of confusion anymore. All right, I don't want the head full of confusion. So you can X out that proof. But I do want to talk about the givens. You have m parallel to n, and n is perpendicular to t. So does everyone see? Now I've given you one set of parallel lines and one set of perpendicular lines. And I'm trying to prove that m and t are perpendicular. So here's the theorem, and it is pretty wordy, and I apologize in advance, but ready. And I'm going to stop halfway through. A line perpendicular to one of two parallel lines. And this is where I'm going to stop. What I would like you to do in your group right now is quickly discuss what line am I talking about right now. Based on your givens, a line that is perpendicular to one of two parallel lines. Please discuss in your group what line are we referring to right now. Hey, Laura.
Oh wait, no.
So you have a line that is perpendicular to a line that is parallel to something else. What line am I talking about? Line T, yes. I am talking about line T in this case. Okay. Is, so if you're talking about line T, not only is it perpendicular to N, it's also perpendicular to M, which we're going to consider a line perpendicular one to two parallel lines is also what? Perpendicular to the other parallel line, yes. All right, so that's a little bit wordier, but now at least you know you got it. Whenever it comes up, maybe I have to use this theorem when I'm given a set of parallel and a set of perpendicular. Okay, we ready to use these now? Let's see. I'll give you a minute. Is it already? Oh, look at that. It's already set up for you guys yet? Nope. Sorry. Go ahead. Do your statements and reasons. Okay. Look at my givens. You can mark your diagram if you want with right angles and parallel lines. That's fine, but we're not going to use anything with right angles at all. We're not going to use corresponding or alternate interior. We're not going to use those. Here's why. Everyone see the first two perpendicular sets of lines. A is perpendicular to S. C is perpendicular to S. In your group, discuss a conclusion and a reason for your conclusion right now. You have A perpendicular to S, C perpendicular to S. Something we've talked about.
Oh, they already told us this is
Nothing about B. Parallel. No, you can't do that the next one.
I'm trying to get you guys to solely use the three theorems we've had and not introduce anything about right angles being congruent. All right, here you go. 3, did you come up with a conclusion in your group? Okay. 3, okay. Okay, A is perpendicular to S and C is perpendicular to S. What do you know about A and C? To what? The same line. And our second theorem we went over, we said if two lines are perpendicular to the same line, what do we know about them? Lines can't be congruent. Two lines perpendicular to the same line. Those lines have to be. So what do I know about A and C? Why? Because they're both perpendicular to what? The same line. Everyone good there? If I have two lines, in this case A and C, that are perpendicular to the same line, line S, they have to be parallel to each other. Two lines perpendicular to the same line are parallel to each other. All right, but I need to get to C parallel to B, though. I have A parallel to C, but I need C and B to be parallel. Use all your givens. What given have I not touched yet? A is parallel to B. With what you just wrote down, A parallel to C. Go ahead, discuss it in your group. You have A and B parallel, and now A and C parallel. What's your conclusion in your group? 21? Okay, to state what? Two lines parallel to the same line are parallel to each other. Yes. So again, we didn't need to. Now, could have this been done differently? Maybe if we said right angles are congruent, corresponding angles, they form parallel lines. Maybe, sure. All right, but we just did it in 3 steps using these theorems. I haven't asked this question in a while, and I'm sure you missed it. What class are we in?
Honors.
We are, yes. So that means we're going to do this proof a different way right now. So do a little dotted line right underneath your current proof. We're going to do this differently. Because, yeah, we started with the 2 perpendicular lines, but we could have also started with A parallel to B, and any of those other lines show up in the other 2 givens? I got A parallel to B. Any of the A or B show up in the other 2 givens? A is perpendicular to S. Oh, okay. Okay. So I'm going to let you discuss it in your group. A is perpendicular to S, and A is also parallel to B. So what about B and S there, huh?
Look at what I did. So you guys are
Read it slowly, because it's a longer one.
perpendicular to one. That's literally what I wrote.
No, a line parallel to
No line perpendicular. Yeah.
Are you saying A is parallel to B because of that? No. Yeah. Yeah.
And then it'd be corresponding.
All right, here we go. What do you guys have as a conclusion? If A is perpendicular to S and A is parallel to B,
2 steps.
12. What do I know now is true?
that B is perpendicular to S.
B is perpendicular to S. And here's why. Because S was perpendicular to A, which was part of a parallel line. So it's got to be perpendicular to the other parallel line. So a line perpendicular to one of 2 parallel lines is perpendicular to the other parallel line. You're not done, though. I didn't need to prove B perpendicular to S. How'd you get to C parallel to B, then? Because we still haven't used C perpendicular to S. So if C is perpendicular to S and B is also perpendicular to S, based on one of the theorems, what's my conclusion? 27, great job. Why did I just go back to it? 8, I got C perpendicular to S and B perpendicular to S. Therefore, perfect. C and B must be parallel. Two lines perpendicular to the same line are parallel to each other. Anything there? I know two different ways. Logan, go ahead.
Could you say corresponding angles congruent lines?
Where'd you tell me they were congruent?
Because they're both. Oh yeah.
You can, yeah, but you got to go through their right angles. They're congruent, then you could say corresponding. All right, but you can't go right to saying their corresponding angles congruent because you didn't write anything was congruent. Anything else? So we're starting to see here, hey, if I look in the givens and I see two sets of parallel lines, if I see two sets of perpendicular lines, or if I see one of each, I can use one of these three theorems. All right, last one here, I threw you a little curveball in the givens. You only have one set of what? Perpendicular lines. So how am I expecting to use any of those theorems? We'll talk, set it up. Okay. So you're kind of like, I can't apply any of these theorems because you only gave me one set of perpendicular lines. Okay, sorry, I'm not going to give you, just spoon feed you the entire time. Can you get me another set? Whether it be perpendicular or parallel lines. Where we are in this unit, can you get me another set of parallel or perpendicular lines right now? Because you also know one's congruent to two. And going into tomorrow's quiz, I hope that lights some eyes up right now. Let's not make words up here. $11. If one is congruent to two, anything I can get out of that? Who's got 11? What type of angles are those? Okay, keep going. They're congruent. What's that usually form if I have a pair of alternate interior angles that are congruent? Which ones? You got it. Be confident. CB parallel to DA. Everyone agree? What type of angles were they, Charlotte? So alternate interior angles congruent imply I have parallel lines. Oh, now you have two sets. You have AD parallel to CD, and you also have what we just wrote down, which is CB and DA. I believe I see a repetition of a line segment there, DA. So within your group right now, if DA is perpendicular to CD and if DA is parallel to CB, what's the relationship between CB and CD right now? You got the parallel and the perpendicular.
One perpendicular, one two parallel.
What is my conclusion for this one? Go ahead, 15. Okay, ready? I'm going to slow this down here because I know that I feel there's mass confusion here. Ready? A line perpendicular to one of two parallel lines. In this case, what is that line right now? Everyone take a look. A line that is perpendicular to one of two parallel lines. What line am I referring to? A line that is perpendicular to one of two. Here are the two parallel lines. CB and DA, right? And what's AD perpendicular to? CD. Here's my line, CD. So here's a line, CD, that's perpendicular to one of two parallel lines. That must mean CD is also CD is also perpendicular to the other parallel line. Just going to take practice. That's it. Okay, I did not give you an opportunity to write down the other two theorems on your index card, so go ahead and do that, and then you can start with the assignment, which again, I'm checking on Friday, has nothing to do with the quiz tomorrow. So again, on the one side of the index card, write your givens. On the other side, write the conclusion and theorem. And then you can start with the assignment.